All right, next in the technical track, we have Martin Holste, who is the CTO for Cloud at FireEye, where Martin is responsible for shaping cloud security offerings, developing the corporate cloud security strategy, and working with customers to help secure their cloud workloads. Prior to serving as CTO, Martin founded the cloud-native threat analytics platform at FireEye based on his popular open-source enterprise log search and archive project. And before that, Martin spent most of a decade serving as the incident response team lead for the state of Wisconsin. And he's going to be talking to us about cloud security, threat models, and mitigations. Let's give it up for Martin Holste.
Thanks. Everybody hear me okay? Cool. All right, so before I get going, it's really hard to know in any given audience how much cloud people are doing right now. So show of hands, anybody using AWS or Azure right now? Ah, very good, about half. Okay, cool. How many are thinking about it or being told to think about it? Everybody? All right, so one thing I've learned, I talked to, I'd say about half the Fortune 100 at this point in the last year or so on cloud. And everybody is going cloud or is really, really sure they're not going cloud. And then if you talk to them about a month later, they had a CIO go golfing with somebody, and suddenly they're all cloud even though they weren't just a little bit ago. And I find that pretty interesting. And then that carries on throughout their entire cloud journey. So if you'll talk to them, in November, they say, oh, we're going completely Amazon. You talk to them in December, we're going completely Azure. January is Amazon again. And it really just depends on where they've put their chips down and what actual experience they've gotten. So what I find throughout cloud journeys, and we'll talk about this a little bit, is that this kind of starts almost grassroots half the time, and then half the time it starts top down and ends up as grassroots. So it's really interesting, and I prefer discussions, so at any time if you have a question, just call it out and we'll try to address it. I hope that we have some pretty interesting stuff to go through here. We get to see firsthand what happens when bad guys do bad things at FireEye on a regular basis. And so we'll go into the anatomy of a cloud hack here in just a bit. So if you are that CIO and you're golfing with somebody that has just done it, they're probably telling you how easy cloud is, and there's a lot of good reasons for that. How many people are managing their IP addresses in a spreadsheet right now? Okay, the rest of the room, your hands were up too, I know they were. No, IPAM is very difficult, and it's actually a really cornerstone of a good security program, because if you don't know where your stuff is or what you even have, it's hard to secure it. Some things like that go away with cloud. So all you have to do is one API call. Now you know where every single thing is, you know where all your storage is, all those kinds of things. So that's great, and your cloud provider salespeople will tell you, this is why you should go cloud, and they're right. That is a good reason to do it. The firewalls are built in, so you don't need to build a box that says deny a packet from point A to point B. That's just a simple bit of config that's already in there. So that part is okay. The asset inventory is there. The patching, so there's, in a lot of the cloud providers, they will have that built in for you. So you say, here's the configuration that I want, and then they'll make sure that that's what happens. It's a little more nuanced than that, but that's certainly a bullet point on their feature list. And there's a ton of auditing that happens as well. One of the great things about cloud is that any action that's of significance will have an audit trail on it, and it's the kind of audit trail that you're not responsible for. The cloud provider is making sure that those API calls are getting logged, and we'll talk about that in a little bit. But that's often a very difficult thing to do in the on-premise or traditional data center enterprise. But there's a lot of hard things that go with this. And for one thing, most places will end up with at least a little bit in multiple clouds, and we'll talk more about what quote-unquote cloud means in a bit. But it generally means that they're getting their stuff from multiple vendors. And I think this is the biggest one. The tools and strategies that you're used to for on-prem suddenly don't line up anymore. And that's partly because things like the IP spreadsheet don't matter anymore because you have other things. The playbooks that you normally have don't affect things that are ephemeral. So if a box exists for, we'll call it 10 seconds, then that's probably not going to be very helpful if you're trying to do forensics, things like that. And that means there's a really big learning curve. So staff is still trying to catch up. It's really, really difficult to go out and hire, I want to say, I want a cloud guy or gal, and I want them to do cloud security. That almost doesn't exist at this point. So and that's kind of good and bad news. I don't think that's necessarily the right way to do it. I advocate for training within, and hopefully that's why you guys are here a little bit, to get that sort of professional development, but I think that's the right way to go, because you need to know your own institution, and there's a lot of legacy knowledge that comes with that. But the idea that there's all these cloud security engineers out there that are just going to show right up the second your HR recruiter goes looking for them is pretty far-fetched. So a lot of that is just training and internal stuff. And then it gets worse. And that's because as orgs get more and more into cloud, they do less and less traditional IT. So less servers, less networking, a lot of the core tenets that you have today, and this all gets blobbed into application logic. And so from the business standpoint, this is great, because now we're having business conversations. We're saying what business action took place, and from a security perspective, the question is, was that what was supposed to have happened? And most places aren't here yet. You might have one or two really shiny apps that are doing this somewhere, and they're kind of this shining beacon of coolness. It can go really, really well. It makes things dramatically cheaper. My previous role before being Cloud CTO at FireEye was leading up an engineering group that took a legacy on-prem, really important back-end service and put it in the cloud. We dropped the cost 10x by doing so with zero operation support, period. That's when things go well. But we stuck to it, and we knew how to do it. And so that is going to be the future. The business will move that way no matter what, for cost savings alone. So whether it's 1 year or 10 years in your organization, it totally depends. But there is a good reason for doing all of this. It really will make the business better. And some of those initial things will come to bear on the positive side. But there is definitely cost. And again, back to that training, you're basically left with app logic when all is said and done, if you kind of take the derivative of what we're getting at here. And that means you're looking largely at audit events. So log and telemetry become real king. And this means that your detection methods for advanced attackers will change significantly as well. So that's not to say you don't need all the stuff you already know, and this is kind of the catch. So I separate this out as traditional and additional, or foundational and additional, with the traditional stuff on the bottom. And I can't say this enough times whenever I talk to people, email security is your #1 most important security for cloud. 9 times out of 10, the bad guys are coming in that way. They're just doing spear phishing. It still works. It's going to work for a long time because it's person-to-person communication. So by all means, that means two-factor, all that stuff, super critical. Endpoint network are still important, and we'll show why in a little bit. So it's not that you don't need to do any of these things anymore. The hope is that by automating a lot of that with some of the cloud things, you'll have more time to do that thing at the top, the additional. And security analytics as a buzzword is nothing new, but it's kind of been that cherry on top, nice to have in security for a long time. And as things get more and more app logic-y, you're going to find that the analytics are actually what become the most important, because you are trying to figure out what happened versus bits and bytes kinds of questions. And that takes a lot of work, takes a lot of skill, institutional knowledge, and the hope is that you can do the foundational stuff faster than you did before, so that your analysts have time to do that additional stuff. All right, so let's talk about specific threats. So these are not just pie-in-the-sky things. This is, on a daily basis, what we've learned. So if you saw the little blurb that we had for this talk, our Mandiant IRs is about, and this is not like a hard number because it totally depends, but between 10 and 20% of all of our IR happens on public cloud. And personally, and this is not scientific, but I take that to be a representation of the total amount of data that is in cloud today, because our attackers follow the data. It doesn't matter what you've done with it or where you put it, they're going to find it and they're going to get there. And so if you kind of go back and say, well, if that's the percentage, and again, this is rough, of our incidents that are happening in cloud, I would say that's where the compute and the data is today. And that's certainly growing if you look at the Amazon and Microsoft numbers. So let's just look at a traditional phishing event. This should be very clear, hopefully, and remedial to the room, but it's, again, I can't emphasize it enough. This is #1 way people are getting in. Stolen credentials, again, through phishing. So there's 2 things you can do to combat this. Obviously, two-factor. Hopefully, you've all done that. This means on your cloud console. So if you're going to your sign-in, all that stuff. It gets much harder with API keys. If you're trying to give an app access, that's basically not going to allow for two-factor. You can get around that a little bit with some IP address restrictions. At the very least, make sure that your cloud console is only allowed from your VPN or somewhere trusted. But that's not always possible, and Google's made a big splash lately with their zero trust stuff. And hopefully you're seeing from the slides so far that IP addresses are going to be a thing of the past shortly as a way to identify things. They just really don't matter in cloud. They kind of sort of matter when you're talking about a console because it's still coming from outside the cloud in. But if you start talking about virtual desktops and things like that, you're right back to them almost not mattering. We're not quite there yet. This is a little bit out there. Some orgs are doing this today, but not many. But that's definitely where it's going. And again, it just goes back to the speed of doing business is the driving factor there. So I said endpoint is still important, and it is. Let's talk about that two-factor. So if you have a hacked laptop, that two-factor is no longer relevant. It's back to zero-factor. And so making sure that you have solid endpoint is still just as important because that might be the vector that they're getting in. And pretty clear from there, if they're on your VPN already because they have a remote access Trojan or keylogger installed, and they don't need two-factor because they're already on that laptop, which is already logged in, so you're in big trouble. So you still need some good endpoint on there to at least hopefully have a shot at knocking that down. You know, our tagline is prevention always fails, and it often does over a long enough period of time. I think about that quote from Fight Club, that over a long enough timeline, the survival rate for everyone drops to 0, and it's kind of the same thing. Given enough time and enough effort, somebody's going to get in somehow, but that doesn't mean it's game over. And then this one is the really nasty one. It happens more, I say it happens more often than it should, but it's not really fair. Humans will continue to attempt things, and humans will continue to fail at things. And sometimes that means somebody's, you know, some dev is under a deadline and they're just trying to get their job done, and they accidentally put something there. Or one of the nasty ways that I've seen it is base64 encoded credentials that a developer might not know are credentials. Azure connection strings are a great example of that. They don't look like an API key or password, but they completely are. They are direct access to something. And that's an easy one to drop. There was a thing out on Twitter about, I think, last month on Trello. So Trello is a way that devs that are doing UI work will communicate to stakeholders what the app, the wireframes, what they want the app to look like. And too often they'll accidentally drop credentials in there. And so there's a Google Doc search that you can put in there that'll find all these passwords out on Trello. It's just another example. GitHub is the more famous one. And we certainly see this. There's not a lot you could do to prevent it, and the problem is it's none of your infrastructure, right? So your only chance is to catch this cloud side. All right, so quick recap. If you're trying to mitigate on cloud side, email's the big one. You're trying to prevent that phishing if you can, and of course, any malicious docs, if you can knock them down, great. Same thing on endpoint. Try to do what endpoint security does, and that extends to lateral movement if you have a direct connect between your on-prem into your cloud provider. That might be a good place to do it. Same with network. Network gets a lot tougher. SSL in general has made network monitoring a lot less valuable than it used to be, and so a lot of this is more about telemetry and figuring out conversations, and you know, you could say it's analytics, and it is. It's also a lot of reporting and just things that look weird, and we'll talk about that in a little bit. And then maybe you'll have a chance to block some exploits if your cloud networking is virtual desktops, VDI. And then analytics is really where you're going to get most of the actual cloud hacks, and that's detecting credential theft, compromised assets, and maybe, if you're lucky, being able to detect exfiltrated data. That changes. Okay, so this is the sort of an amalgamation of several incidents because we never name names on our stuff. But this has a lot of the important points from several incidents kind of put together. First thing to note, there's day 1, day 2, and day 3, so that's only a 48-hour time period. We're seeing a dwell time of about 48 hours for cloud hacks. That's very, very different than on-prem dwell times. And if you think about why, it's basically because, as the very first slide I talked about cloud is easy. Well, it's easy for the attackers too. So an attacker is basically a rogue administrator at this point. And if they want to know where all your stuff is, they'll run one API call and find all of your stuff with all it's appropriately tagged and all these things. If you're an attacker, well, actually, if you're an employee, think how long it takes for you to find out where stuff is, right? You think, talk to whoever has the spreadsheet or the CRM or the SharePoint or whatever. An attacker's got to do that same thing. They have to sift through email. They have to constantly noisily scan drives, things like that. An attacker in the cloud just does one API call. And it's the same API call for every victim that they're going to attack this week. And it's the same API call that they can practice in their own local account or their own personal account to make sure they get it right so that when they actually go after somebody, they've got their whole playbook down and they know it's going to work. They may even have a template for it, which is extra scary. So that's why it can happen really quickly, and that's why I look at a 48-hour dwell time between the time that they initially get in and the time that they've done what they came to do. So on the day one, they're in with stolen creds. Again, that goes back to why phishing is such a big deal here. And again, endpoint, any way they're going to get those credentials. Now, I did, at RSA, I gave a whole workshop this year on how to get in through serverless. And it's using, basically, if you're familiar with SQL injection, you can apply that to, to function as a service or Lambda if you're trying to inject parameters. And there's a whole other thing on that. So there are ways to get through. But I will say that things like serverless and containers generally do raise the bar for attackers. It is a lot harder to hack those things. There's not an operating system that needs to be patched, so that's good. They're basically reduced to programming error and libraries that have known vulnerabilities. That's really, for serverless containers, your only point of entry as an attacker. So that's good. I mean, that's basically a win. It's a lot harder than if it's a virtual machine which has all the underlying liabilities attached to it. But none of that matters if they have credentials. So 9 times out of 10, they're coming in that way. And then they may do something very interesting by dumping data via API calls. And what I mean by that is, you guys are well familiar with backups. If you were to restore a backup to another on-prem box, that would negate the need to log into the original server. No different in cloud, it's just even easier because you don't have to go and find the Veritas backup server or whatever it is. It's just a snapshot that's the same for every other thing in cloud. And you push the same button, you can test yourself locally, and it'll mount that snapshot on a box that you have access to. So let's say that you came in and you don't have full admin privs, but you can still create a virtual machine and you can still attach a snapshot. That's the same as being given the Oracle login to an Oracle server running there, because you can't fight that off with firewall rules. You don't need a security group for that. You just need the privileges to be able to mount a snapshot. And we've seen that abused several times, and it's especially nasty because from an audit perspective, there's just one API call, and that's it. There's nothing else to see. And then once they've rummaged around in there, they'll dump the data. There's a lot of ways they can do that. It might not be the very noisy transfer out to some FTP server like we were so lucky to have 10 years ago. It may be one more API call that says, I want to now replicate everything that's in this bucket to a bucket I control, and henceforth I will receive all the data that ever goes into this bucket. And if you didn't see that one API call, well, you have no idea this is happening, and you can't do a PCAP on this, you can't do any sort of IP telemetry, that thing just happened. So if that sounds scary, it a little bit is. The plus side is that that API call will exist, and the attacker can't do anything about it. So you do have a fighting chance here, but you have to know what you're looking for. So, our opportunities for detection. There may be some very simple things here, and I'll have a few more bullet points. I think it's really important. If you have ever worked in the SOC or work there currently, if somebody gave you an alert that said, hey, there's a login from a new IP, you would try very hard not to punch them in the face, because that is not an interesting thing. You say, okay, thanks for that information, and then you go about doing something important, because someone that gives you an alert that says there's a login from a new IP, unless you know specifically that this thing never gets logins just off the top of your head, not very interesting. And same thing with the new user agent, that's even less interesting. You start adding these things up in a short time frame with what I'll call correlation, then you might be onto something. And if you add a few more, now you definitely have something interesting. So if the data were presented to you, as in you had a login from an IP, new user agent, there was an anomalous amount of API activity, or there was a new kind of API call, I will tell you that the mounting of snapshots is usually quite rare. And so if you see that, that might be worth investigating. It's not necessarily malicious, so it's not something you want a giant red alert for the SOC to investigate necessarily, but it could be very interesting. So I would say that each one of these are very good for hunting. So if you're trying to, if you cleared your alerts for the end of the day and you want to know what's next, just taking a look through some of these, and at the very least, even if there's nothing bad going on today, you'll be establishing a baseline. So that's a good thing if you're working in the SOC. And then you might even get lucky with a new IP logging into a well-known production database or something like that. Again, I'll point out the institutional knowledge here that the SOC operator needs to know. So if you're a service provider, you'd have to be an awfully good service provider to know that this is a specific kind of database that has this application attached to it. If you're really good about tagging and things like that, maybe you're able to put together the informational infrastructure to get this communicated to your service provider. But that's pretty rare. And so I think this highlights the big challenge that we have here is as you go into the business logic side of security for this, it is even more and more important that people are communicating and that there's some understanding of what the business is actually doing. Because the easy stuff, finding IDS signatures, those kinds of things are slowly drying up in a cloud environment like this. It's not to say that they don't exist at all, but this is certainly where it's headed. Any questions about that before I keep going? Yeah, over here.
Sometimes cloud providers allow you to encrypt your database. Does that help?
Great question. Does database encryption help with any of this? The answer is no. If the application can read the data, then it's not encrypted anymore when the application gets it, and that's why this is all about app logic. So it's not necessarily about mounting those. Now, I will say one extra bar raised on the snapshot thing. The attacker will need to have privileges not only to mount the snapshot, but also to grab the keys that are associated with that. However, that is almost always the case. Because it doesn't make sense to have someone with privileges to mount the snapshot and not also be able to decrypt it, and that gets used against you. Great question. Shout out another one if you have one. I'll just keep going here. So there's two kinds of ways that companies go into the cloud. Sometimes they're at the same time, but usually if they're just starting out, it's going to be on the left side with the lift and shift. And so that's this idea, back to the golfing match, where the CIO said, oh yeah, let's just do all cloud. And so they say, hey, we have a data center, it has virtual machines running in it, let's just punt that all to the cloud. I generally see companies do successfully save money this way, but it's not because they're doing anything special in the cloud. They usually save money because they have what I call the garage sale moment, where they start to look at everything and they're like, no, we don't need that anymore, we consolidate this, we don't need that anymore. And that's kind of on the plus side. On the minus side, they're usually not mature enough to know how big a machine that they need, so they'll dramatically over-provision the virtual machines that they do purchase or rent, or however you think about it. And so generally speaking, they come out mostly ahead. But I will tell you, if you're doing cloud migration and you're doing it wrong, you're going to lose a bunch of money. So you can gain a bunch of money, you can lose a bunch of money. You have to do it right. And then the nice thing on the lift and shift is that you can kind of replicate what you have on-prem from a security posture. So you can go out and buy your favorite firewalls, you can do your favorite endpoint, put all that on there. And it'll basically look the same as it was on-prem, but you don't have to worry about things like the price of diesel fuel for your backup generators, and that's all good news to the CIO. But as I said, there's not a whole lot to initially be gained from there other than some better management. On the right side, you have the re-architected. And this is where, as I said earlier, you can see 10x savings depending on what your application is doing. This is where everything's going and where it's going to be the most beneficial. But the problem is that this has the least amount in common with what you know today, and so it carries the largest risk. The platform itself can be used as a giant computer, and all the things that we've learned over the years that you can use as an attacker to hide in a computer can be used against you. So for years, attackers have used things like Linux and Unix cron jobs to schedule tasks in Windows. And so that's a way to make sure that if you delete a file, it'll get recreated, things as simple as that. It's much more sophisticated now, but that kind of scripting still exists. You could do that same thing cloud side. There's a YouTube video a couple of years ago from a convention out in Europe where they showed how you can delete an AWS Lambda that was running and have it schedule the creation of itself later. And so if you go to the console, there will be no Lambdas running, but there is code executing all the time. It's just one example of how you can hide in a cloud platform and how the only way you're going to see it is on those audit logs on the backside. I'm talking a lot about business logic. Another case of this is CRMs that are cloud side. So I came across this on a forum a few months ago, and it was really interesting to me because anybody heard of Joanna Rukowski? She's pretty famous in the security industry. And she has a thing called CubesOS. She put that out, she started work on that almost 7 or 8 years ago, I think. And it's been commercialized and it's out there, but it's still fairly esoteric. And this post was from just a general IT administrator. And for them to be at their wits' end trying to protect these HR recruiters, to think about putting something like CubesOS on an HR recruiter's laptop really kind of spoke to me as an anecdote about where we are today. because for the life of them, they could not keep these people from getting hacked every single day. And the reason is they have to take 200 unsolicited Word docs through the spam filter and open them every day, which is exactly what you're training your people not to do, right? So that's a great landing pad for any attacker, and they know it. So they start applying for jobs, so to speak, at a rapid clip. And so the question is, well, what are you supposed to do about that? Certainly email security is a big part of this. But what if you're using something like Newton or some of the other apps that are taking, they're a cloud app and the application comes in that way? That's not going through your email security, so you don't have an option to do that. And this is true of any app that you have that is taking uploads from users, period. Unless you're doing very strict byte-level checks on what's coming through, that's an avenue of attack. And what can we do about that in the cloud? So basically, you need a way to hook in something for each one of those docs that's going to be a little bit better than a spam filter and try to actually provide security there. At the very minimum, as a practitioner, being able to get some sort of forensics on that so you can go back and see what that Word doc was is going to be really important. So working with whoever's doing your cloud admin, whether it's your own internal IT or whatever, having access to that bucket or blob storage or SharePoint or whatever it is going to be really important. And this is the kind of thing that gets left out of a lot of general security setups. They think, well, we've got the network covered, we've got the endpoint covered, we've got email covered, we're good. Yeah, except for all the ways that the attackers are coming through on these kind of other areas. And these are the exception, not the rule today, but this is going to grow exponentially in the next few years. And so I'm trying to tell you up front, this is what you're going to have to start looking at. And it's a lot easier if you build this into the conversation early. Hopefully you guys have some voice at the table when people are considering new applications. That's not always the case. But this is one thing to point out. Hey, how am I going to get visibility into these docs as they're flowing through this workload? This one keeps me up at night a little bit, data alteration, especially in the context of elections. This has become very problematic of late. Fortunately not here yet, but in other countries. And so the big question is, well, stealing data is bad enough, what about altering it? So in my workshop that I did at RSA, we ran through an online banking app that got its data altered in such a way that you could conduct a fraudulent transaction. And this is just a really specific example, but this is very common in the banking industry. And so the idea that I'm trying to point out here is this legitimate source data here gets converted into training data, and it goes through all the ML. Now, whether it's a buzzword here or not, even if it's just basic reporting, let's say it's a report that they run every night that says what were the top transactions of the day, something like that. You can generalize this very easily. And the point is that training data needs to be just as secure as the original source. So if you think about, let's say, a really important Oracle financial database that has, armed guards around it at all times. This thing is keys to the kingdom, so it's got a ton of virtual security cameras pointed at it all the time. And then they do a nightly export. Maybe it's anonymized, maybe it isn't, and that goes into some of the nightly batch reporting. Is that batch file just as secure as the original database? The answer is usually not. Hopefully it is, and often it is, but to say that it's the same thing, because they might say, well, it was anonymized. Okay, well, if you change the anonymized data that goes into what gets evaluated for fraud transactions, then that's just as bad if the attacker knows what they're doing there, which if they've been in the network for a year, they absolutely do. All right, so you fight all this with visibility. Last year in our M-Trends, we didn't focus on it as much this year because we did last year. But this was really cool to see coming out of our IR folks. I didn't have to ask them to put this in. I was able to just glom onto what they had already written, which kind of tells you a lot about our company. We just go and see what the bad guys are doing and then try to explain that. And they were pointing out that monitoring is really where the majority of the fight here is. So in that doc, they had these 4 bullet points, which I thought were great litmus tests for how well you're doing. These are a pretty high bar for most places. And the key here is that these are not one-time actions. This means, does your SOC on a daily basis do A, B, C, and D here? So can they see what files are being downloaded from cloud-based storage site? As in, is that completely instrumented? Does that come in to the SOC? If there is an incident that occurs, will they be able to correlate that with what's going on? Or is this going to be an hour-long operation getting people on the phone to do a dump that they then have to meticulously pull in and go through in a CSV file and all that stuff? that's what you do for a full incident response after something really bad has already happened. If you're trying to prevent the really bad thing, then you need to do all those things every day and have that operationalized. This extends into admin logins. It's a little more obvious, but I think it's still really important. And this comes back to that people aspect. So do you know who's traveling and who isn't? Because maybe there's a legitimate reason for them to be logging in from a weird place. That might require a phone call. And the amount of tickets that come through a SOC is very high, and the amount of time they have is very low. So the idea is to try to automate as much as possible, knock down the easy stuff, so they can actually make a phone call to someone who might sit next to the person who's traveling and find out whether or not they actually logged in. It seems like a small thing, but that can be the difference between a really bad problem and something that's swatted away easily with password reset. Unauthorized provisioning of cloud infrastructure. So if a box boots, does the SOC know why the box booted? That's a really, really hard thing to do. You can even do things like it has to come up in a template or through standard means. Maybe that's a CI/CD pipeline, all those things. That helps a lot until the attacker has credentials to the CI/CD pipeline. Then it's a little bit harder, but that's a good first step. No random box boots. That's a good rule to at least start from. And that's not easy, just that first kind of rung on the ladder. And then what are you getting from your cloud provider, and is that getting into the hands of the SOC and then incident responders? So are all those cloud logs centralized into one place? And as we talked about earlier, you often have multiple cloud providers, and so that becomes very difficult. So I look at visibility itself in 3 domains. The 2 are pretty obvious. I kind of just do a lump sum of events, which would include everything else, and it's kind of the breakdown. So the provider is going to have 4 types of basic logs: audit, flow, security, and app. We'll dive into that in the next slide here. The endpoint logs are still going to be really important. Even if that box is only booted for 10 minutes, what happened in those 10 minutes is really important. So make sure that you're getting those logs off of the box into somewhere that you can later search, because the box itself is going to be gone. That's even more true of function as a service, although it's a little bit less of an issue. And then same with containers. As I said, both functions and containers are inherently a little bit more secure from a base platform scenario. Not to say that they are secure in and of themselves, but they don't have all the problems that VMs do. So I still encourage people to focus on the VM security first. And then that doesn't mean that all the stuff you had on-prem goes away. So even if you're in a box moratorium and it's just laptops, still relevant and still very important to match up what's happening server side with client side. And so getting all those things into one place can be critical. And then I have actions as the output here. Again, back to the automation. Because there's so much more app logic involved here, that SOC needs time to do the human stuff, and that means all the machine stuff should be done by machines whenever possible. I will say very few organizations are succeeding at doing that today. So if you're not one of them, don't feel too bad. If you are one of them, come up here and I'll give you an award. We'll sketch one out. It'll be great. So those are the 4 basic log sources that you're going to want out of your cloud. So you have something kind of concrete to look at for AWS and Azure. I have these types up here. That top line is by far the most important. That's how you're going to catch logins from nefarious places. But the CloudWatch and the activity logs from OMS are still very important. That's where a lot of your app logic is going to come from. So if you do have a bunch of malicious Word docs being uploaded into one of your apps, you're probably going to at least have a file name in CloudWatch or OMS. And so if there's pushback from when you, the security person, say, hey, IT people, I need these logs into our security system, they say, it's too much or whatever, we don't want to do it, remind them that that's probably your only viewpoint into the inner workings of how this stuff goes, and if they want to actually know what's occurring and when that stuff is bad, they're going to need to do it. So sometimes it's an easy conversation to have, especially if you can then give the IT people access to it. But it can sometimes be pulling teeth, so it's battle worth fighting. The network flow logs, talked about that a little bit earlier. If for no other reason, you can usually get some low-hanging threat intel out of that if you can match it up. And then the conversations in and of themselves are very valuable to just be able to say, at the very least, I know that this box talked to this box. Now, big caveat there, just like on-prem and data centers, if you have a box in the same subnet with another box, there's almost never a record of that thing talking from something other than your endpoint security. Very true in the cloud. Your cloud provider will only show you stuff that went through a router. So if it's within the same security group, you generally don't get visibility into that. And I will also point out here that as of today, there is not a great way to do a lot of the network visibility in general There are add-ons where you can run an agent on a virtual machine in the cloud to get something akin to a span port, but it's much more difficult and takes a lot more cooperation with the people doing deploys to get that, so don't expect to be able to just get something like a span or tap session in the cloud right away. And then lastly, there are some basic security logs you can get. AWS came out with something called Guard Duty in, December of last year, and Azure has something called Security Center. That's great. Even if I weren't from a security vendor, I wouldn't. They're fine. They will get. Like Guard Duty especially is very low cost, so there's no reason not to run it. Security Center is a little bit more, so you have to maybe pick and choose. But yeah, throw Guard Duty on there. That's fine. But the amount of don't think that because you have that on there that it's going to catch stuff. You know, it's like a 1 in 100 chance that it's going to catch stuff. Especially if it's even remotely like a targeted attack or even a good attack, because those are generally relying on stuff they've seen before from IPs that are known to be bad, and so that you'll see a lot of like scan traffic or attempted login traffic, and that's nice. But again, if you are the SOC guy or gal, you're not going to do anything with what is essentially the system working correctly. They tried to log in, they failed, and they're now trying to log in somewhere else. That's not actionable, right? So that's generally what we see there. But sometimes, you know, maybe you'll be lucky and you can correlate an attempted login there with a successful login later, something like that. So, you know, throw it in. Generally speaking, we look at cloud as just another premise for the most part, and may have more advanced applications that run on that premise, but we need to remember that we're trying to pull things from everywhere. So you saw that visibility before had on-prem plus you know, 1 or 2 or 3 or 4 cloud providers, and getting all that centralized is critical. The other thing to remember is that just like on a Windows box that's running, you can clear the logs. On a Linux box, you can clear the logs. An attacker, if they have access to something like CloudTrail, can delete all the CloudTrails that were in the bucket for, you know, historically. They can't do it for like the last 6 hours, but they can do it historically. So you want to get them into another account if possible. And there's a lot of easy ways to do that. And then lastly, SaaS is still just as important as ever. So all these things are still relevant, and this demonstrates even more how things are moving towards app logic. And if you apply those kind of litmus tests I talked about before, would you see a Salesforce login? Would you see a ServiceNow login in your normal SOC infrastructure? Could you do reports on that across all the different SaaS components that you have? I was just at the IoT talk before this, and you know, it's hard to know where all the IoT devices are. Very similar for SaaS. It's really hard to know all the SaaS logins. I mean, you know, Google Drive on personal accounts alone is a big problem. And then, of course, any virtual desktops they have running. I see this picking up quite a bit, things like running Citrix and AWS workspaces and all the various ways you can do remote desktops in Azure. That's picking up considerably. So lastly, these are sort of the main checklist items. So protecting those credentials from phishing, that's still #1 thing you need to do, and mention all the ways to do it: 2-factor, good spam protection, good phishing protection, all those things. The endpoints are still critical. Protect the cloud networks as best you can. Again, that's very difficult right now other than flow logs. And then the additional stuff that you didn't know you had to do before. So collect and analyze all those platform provider event logs. Even if it's just collecting, that is a huge, important first step. And then protecting any business apps that are receiving files. Those are really being targeted right now. And then lastly, making sure that you're keeping an eye on the SaaS data. Going through your proxy logs is a great way to do that. Centralizing CASB logs, just as important, all those things. All right, questions? Oh, good question. So the question is, for law enforcement, do you go to the company first to get the evidence, or do you go to the cloud provider? It's almost always the company contacting the cloud provider on their behalf. So from our perspective, since we're not necessarily law enforcement, we work with law enforcement a lot. The company has come to us and said we need help, and so we'll work with the company and the cloud provider to get what's needed. And I will tell you that if the cloud provider doesn't have it, there's no like, oh, this is our public statement that we don't have it, but really if it's a big deal, we have it. That's not the case. They don't have it. If they say they don't have it, they're not going to give it to you. It doesn't matter how important it is. So whatever they have stated is true. And so that means like if that CloudTrail gets deleted, it's gone. They're not going to, you know, check deleted files or rummage through backups or something for you. That doesn't exist. It's not going to happen. Providers don't do that because they can't scale that kind of thing, and they deal with requests like this constantly. Oh, all right, thank you very much.